Welcome to qnawire.
Hello guys, here we are given two blocks A and B and their masses are 5 kg and 4 kg, and what we have to find out is that acceleration of each block. In order to find the acceleration of each block, first of all we need to make free body diagram of each block and find out the net force on each block. So here are the free body diagrams of each block. Let's say that the tension in the rope is T. Then this is same everywhere because rope is connected with a frictionless pulley. Adding these two components will make here tension to be 2 times T. So the net force on the block B is upward 2 times T minus 5G. Here G is the gravitational acceleration and net force on block A downward is 4G minus T. And we know that the net force on any object is equal to mass times acceleration. Mass times acceleration. So here mass is 4 kg and acceleration is what we have to find out. And here mass is 5 kg and acceleration, let us say a b. Here still we have two equations and three variables, t, acceleration of block A and acceleration of block B. So technically it is not possible to solve three variables with the help of only two equations. So we will have to find out one more equation which will be relation between acceleration of A and B. Let's say that block A comes downward by a distance d. Then the length of rope in this side will increase by d plus d, and this extra length of the rope will come from this side. If we pull this block A downward, then technically block B will go upward by some distance, let us say d dash or db, and denote this by dA. Let us say that this pulley goes up by a distance of db, then the each side, this side and this side, will lose the rope by length of db and db. So this side will lose a total rope of length 2db, and this side will get an extra length of rope by dA. So technically the length of rope lost by this side will be equal to the length of rope gained by this side. This is how 2db will be equal to dA. By differentiating this equation two times, we will find acceleration of B will be equal to acceleration of A. Now replace acceleration of A by 2 times of acceleration of B. 2 times of acceleration of B into this 4 kg will be equal to 4g minus t, and this equation will be like 2t minus 5g will be equal to 5 acceleration of B. Now we have two equations and two variables. T equals 4g minus 8ab, 2 times t, 4g minus 8ab, a b will be minus 5g will be equal 5 times acceleration of B. After solving this equation, we found acceleration of B equals 10 upon 7 meter per second square, and acceleration of A is twice of acceleration of B, so this will be 20 upon 7 meter per second square. Here for your convenience I have taken the gravitational acceleration 10 meter per second square. So this was part A of this question. Let us move to the part B of this question, which says that 2 kg and 5 kg blocks are connected in this way, and find out the acceleration of each one. Let us say that block B moved down with the distance of dB, and pulley comes here after moving. So dB length of the rope will be added here and dB length of the rope will be added here. This is how total increase in the length of rope here is 2 times dB. And if you assume block A is moving towards the right with the distance of dA, and after moving distance of dA, block comes here. So technically decrease in length in this segment will be equal to increase in length in this segment. So 2 times dB will be equals to dA, and differentiating this equation 2 times will get us 2 times of acceleration of B will be equal to acceleration of A. Now let us say that the tension in the rope is T, and this T will be equally distributed in the entire rope because the rope is connected through frictionless pulleys. Same here and also here. Tension in this segment will be 2 times of T due to the vector sum of these two vectors. Now if we make free body diagram of each block, then we find this is B and downward it is 5 kg. So the weight is 5 kg times G, and upward the tension is 2T. So net force downward is 5G minus 2T will be equal to mass times acceleration of B. And if you make free body diagram of block A, then we find that tension T is the only force acting on the block A. So the net force will be equal to mass into acceleration of A. Now using this equation here comes 2 times of acceleration of B equals 4 times acceleration of B. Now we have found out the value of tension in the terms of acceleration of B. Now we are going to put this value here. It will result as 5G minus 2T equal 5G minus 2, and T is equals 4 times of acceleration of B equals 5 acceleration of B. After solving this equation, we found AB to be 5 times acceleration of gravity divided by 13, which is almost 50 upon 13. Now for the acceleration of A, which is twice of acceleration of B, it will be almost 100 upon 13. So finally we got acceleration of A equals 100 upon 13 and acceleration of B equals 50 upon 13. Alright, moving on. This is the third part of this question. It is almost similar to the first and second part. In the same way, let us assume that the tension in the rope is T, which is equal at every point of the rope, and these two vectors will result here tension to be 2 times of T. And if we move this 2 kilogram block downward by a distance dA, then as we have seen before that this block B will move upward by a distance half of dB, half of dA, because if we assume this to be dB, then 2 times of dB will be equal to dA, and this is how dB will be equal to half of dA. Okay, differentiating this equation 2 times will result 2 times of acceleration of B will be equal to acceleration of A. Now let us discuss the free body diagram of each block. This is the block A. 2G force downward due to gravity and the tension T upward due to the rope. So total force downward is 2G minus T will be equal to mass times acceleration. Mass is 2 and acceleration, let us say A, which is equal to A B into 2 and this 2 here. so it will be equal to 4 times of acceleration of B. Now discussing the free body diagram of block B, 1 into G downward and 2T force upward. So the net force upward is 2T minus G will be equal to mass into its acceleration. From here T will be 2G minus 4AB. Putting this value in this equation, we found 2 times T, 2G minus 4 times AB minus G equals AB. Solving this equation, we found the value of AB equals 10 divided by 3. And acceleration of A will be equal to 2 times of acceleration of B equals 20 upon 3. So here we find out that the acceleration of B is 10 divided by 3 and acceleration of A will be equal to 20 upon 3 and meter per second square. Hope you guys learned something new from this session. See you in next session.